Welcome to Miss North's Geography Shorts, and today we are going to do some virtual field work. So we're going to do an investigation on how water soaks through, infiltrates different surfaces. So to start with, every bit of field work we need an aim. How does the rate of infiltration vary according to the ground type? If you want to have a go at the fieldwork yourself and it is safe, then please do. Otherwise, if you watch this whole clip and use the rewind and pause buttons to have a go at the write-up part yourself and use my results. So we know our aim, now we have to think of a hypothesis. So a hypothesis is a statement that will be tested through our investigation. So my thoughts are infiltration rates will be greater on sand compared to concrete. This is because sand is more permeable. So that means sand will let through more water. Then another part of your write-up would be your method. So this would be a step-by-step instruction of how you'll complete your fieldwork. As always, there's some keywords that are really good to use in your write-up. So if you just press pause, have a read over them and try and get some into your writing.
It's finally stopped raining and we have a nice day. So we're going to do our virtual infiltration experiment. So if you can get outside safely, what you need is a jug so you can measure how much water. I've got a can, but you don't particularly need that, but it does help. Water, obviously. My sheet that I'm going to record the results on, and I'm going to use my phone as my stopwatch. So our first spot will be sand. So here we have our sand. As it has been raining, it is quite wet. We've got 200 ml of water. I'm going to pour this in and we'll time how long it takes to disappear. So this is our second site. We've got stones, 200 ml of water. See what happens. Gone. So our fourth site is grass. So we've got our 200 ml of water. Let's go. It's gone. So site 4, we've got astroturf. 200 ml of water. Gone. So the fifth site, pavement. I'm going to have an educated guess that we might be here a little while. So 200 ml of water, it might leak out the bottom. It probably will. Here we go. Yeah, it's all leaked out. But as you can see, it's staying on the surface, so I'm going to keep this running. As you can see, it's trickled its way all the way down here and it's collecting. So I'm keeping it running as the water hasn't infiltrated anywhere, it's called surface runoff here, moving across the surface. And we're coming up to a minute and there's still no sign of this puddle disappearing. So I'm going to call it a day there. So site 6, we have bare soil. 200 ml of water again. The ground is quite saturated because it has been raining for about 100 days. But let's have a see what happens. 200 ml of water. In we go. Oh, it's leaked a bit out the bottom, but still infiltrating a lot slower than the other ones. And it's gone.
So here are my results. I've taken an average over 3 tests to get a more accurate result. By doing this, I've added each one up, then divided it by 3. A little bit of maths. Then we can continue our write-up. So we need to analyse our data. Again, like in maths, we can plot our data on a graph. We then need to describe this. So what surface had the highest infiltration rate, so the quickest? What surface had the low infiltration rates, the slowest? Then we can move on to our conclusion. Does the type of ground affect the rate of infiltration? Well, I would say yes, definitely. But why? So concrete is an impermeable surface, therefore no infiltration took place, whereas stones had a high infiltration rate, meaning the area was very permeable. Then finally, we can move on to our evaluation. So what went well? I would say we proved our hypothesis. We can link it back to the start. So this went well, we came to a conclusion. What could we improve? Well, maybe we could use a bigger can and make sure this is tapped into each surface properly to stop any surface runoff. That could make our results more accurate. And then finally, what impacts on the experiment were there? Well, I would say the fact we have had a lot of rain has impacted our experiment. The surface may already be close to saturation, affecting our results, so it might be worth trying this in a different season or when the ground is a bit drier. But anyway, that's a whistle-stop tour on taking out field work for infiltration rates. Thanks for watching.